Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lecture, we have been looking at software engineering. For today's session, I will be discussing on requirements engineering. To talk more about this requirements engineering, as we have discussed in the earlier discussions, earlier sessions we have indicated saying requirements engineering plays a vital role towards development of the software, because we try to get in as many suggestions from the customer as possible to develop the software. Some of the learning objectives for this session include to give a general introduction of requirements engineering process, to describe the principal requirements engineering activities and their relationships, to introduce the concepts of user and system requirements, and to describe functional and non-functional requirements. So, when we wanted to understand the software requirement, which actually means a description of what is to be developed. So, the customer will get an understanding of what is to be developed, which will be translated to the developer by their native language. The developer will elicit all the requirements that the customer wanted from the customer, will convert all that into the actual format for developing the software, then he will proceed with the development. So, this is what is the requirements phase. So, this requirements is a complete description of what the software system will do without describing how it will do. So, when we talk about how it is to be processed, it is all a technical thing which the customer may or may not be aware of. So, we get into the requirements with a stage of what is to be done rather than how it is to be done, and the same will be represented by the requirements engineering process. So, the software requirements may initially give abstract statements of services, like I wanted a software for inventory management system, by where it is all clear what an inventory management system is. I wanted a software for library management system. How complex is the library becomes a secondary issue, but then by the word of library management system, I will be clear of the first level, saying a library management system basically needs such activities. The second requirement that a customer would need is part of the bid of contract. So, after collecting the requirements, the developers will work on how many lines of code that we may have to do, how is the actual blueprint to be done for this, how many people are to be employed for doing all this work. So, based on that estimate, they will come out with a cost model. So, they will go for a part of bid of contract, the actual contract by itself, part of the technical document which describes the complete version of the product. So, by where I understand the entire requirements from the customer, which means I elicit the entire requirements from the customer, I am making myself very clear that can I proceed for such a development. And today we see most of the products are based out of automatic. So, because of this automation, we could do things much faster. So, it gives us a clear description of what this product is rather than gives us an understanding of how it is being done. Looking at the sources of requirements, who are the major sources of requirements? They are stakeholders. We provide as much documents as possible. Some system that has been existing, I will have a role model of certain systems which has already been developed and in practice, then the application domain. So, these four becomes the sources of requirements. Some of the importance of the software requirements, this is just a survey that has been carried out in 2014 by Standish Group. They have made a survey to study the three most commonly cited factors that caused projects to be challenged. If you look at the entire projects that has been taken up in the past few years, this survey clearly shows because of lack of user input, project fail because of this input 13% of the major work. So more than 13% of the projects fail because of no clarity in the initial user inputs. And some projects might also have incomplete requirements and specifications. So that is counting to 12% of all projects. And there will be changing requirements and specifications. This requirement, once having given, will not be the same for the entire duration. If the project duration specified is 2 years for its development, this project can change between those 2 years. So there will be change of requirements and specifications. So 12% of all projects will be taking its failure time. So what is important about this software requirements? So because of this particular study, there is a diverse data changes. So the data diverges very rapidly. Your project could fail because of unrealistic schedule. As I have already indicated, unrealistic schedule means I can think of all the requirements which my customer has given and say that this development could take a minimum of 2 years. But this 2 years gap can fetch out so many products, such products into the same domain. Today you see a lot of competitions that has been happening between one website or other. If you wanted to go in for a travel booking, there are so many websites which compete each other in terms of its cost and the time of booking. So if I spend most of my time or major of my time towards developing a software, or if I drag the development towards say 2 years, between that time gap there can be a vast development. So there cannot be unrealistic schedule or a time frame. So 4% of project cited this as a reason. And point number 2, it becomes inadequate staffing and resources. Although there is a large quantum of staff available, but then appropriate source of people who can work on this project will be only 6%. So 6% projects might fail because of this specific reason. And the third point that we wish to talk about is the inadequate technology skills. If at all I find appropriate people towards this development, there are likely chances that I may have to train or they may not be exposed towards that particular technology, because of which 7% of the major projects fail, or for various other reasons, like the survey shows that at least 1/3 of the development projects run into trouble for reasons that are directly related to requirements gathering. That is, I am trying to collect as many requirements as possible from the customers and from different stakeholders, requirements documentation and requirements management. So on gathering all these specific details, I will be very clear of what is to be developed, then only I can convert these requirements into a blueprint design. So between this time gap, we may have to estimate on the requirements error also. So we will look at what is the frequency of requirement errors that happens. We look at the defect origin, say starting with the requirements phase, moving on to the design, coding, documentation, and in terms of bad fixes, bad testing, and in total. The efficiency, removal efficiency, the identification and removal efficiency has been, if it is noted at the requirement stage, it will be only 77%. So the delivered defect will be 0.23, whereas when you compare it with the other stages or the other phases of your entire life cycle of software development, it will be more than 77%. So what we mean to say with this particular slide is, if it is identified very early that these are all the possible errors that can be very easily rectified so that this project might lead to a success, then it should be appropriately given a mention. So requirements error top the delivered defects and contribute approximately 1/3 of the total delivered defects to the defect pile. And for today's generation, although we have done so many projects and we say 99% of our projects are being successful. There are companies which say 99% of the projects are successful, and then they say 99% of the projects are error free or defect free. But then nobody could say that this kind of a projects will be 100% defect free, for a simple reason that between 99 and 100 it is only 1%, but then bringing the entire product from 99% to 100% takes in double the time of the effort when compared to the actual development. If you could rectify the errors at the early phases, high cost of requirement errors. So, if I could find out my defects at the early stages, then I will try to reduce the entire cost of its development. So, the defects discovered, if it is found at the requirements analysis phase, it will affect only 74% of the requirements oriented defects. Whereas, once when I have drawn myself to a high level defect, it becomes 4% of the requirement defects leak and 7% leak further into a detailed design. So, from 4% it will get on to 7% leak. Why? Because it has been transferring all that error that has been identified from the requirements to the design phase. So, the leak percentage will automatically increase. So, this leak continues throughout the life cycle, and a total of 4% of requirement errors aren't found until maintenance. So, till the stage of maintenance, which is at the last phase after the delivery towards the customer, I will not be able to manage the entire requirements, which might cost myself with a heavy amount. So, when the system is released to the customers and it is likely in full scale operation. So, early the better. So, what we identified early, if it could be rectified in the early stages, then this may not cost us heavy. What are the possibilities that requirements error can lead us to? It can lead us to re-specify the entire documentation or re-specify the entire requirements gathering that we had. We may have to redesign, we may have to recode, retest and change the orders of it to get executed, and we may have to at times perform corrective actions. Sometimes the entire project or the entire quantum of work that we may have done should lead to a scrap, or some portion of it which we would have given a highest concentration might lead to a scrap, warranty cost, product liability and service cost, and we may have to work on the documentation also. So, poor documentation and all these aspects might not fetch a very good quality product. That is the ultimate objective of us. So, if you look at the types of software requirements, we have two major types as per the software requirements. One is called a functional requirements, the other one would be a non-functional requirement. Functional requirement is too technical, where we describe a set of input, behavior and output. So, what sort of input can be fed into the system? How does the system behave or respond to the queries which have been given as input, and the output? Not only that, we may have to do some calculations on the functional requirements. We will work on technical details, data manipulation and processing and other specific functionality that define only what of the system that the system is supposed to accomplish. Functional requirement should be complete and consistent. So, whenever I am talking of specific thing in terms of its functionality, then I mean whatever that I have projected as a functional requirement in terms of technical activity, that need to be complete. Basically meaning I am very clear with what I have given, my objective has been done, the scope of the work is being done. So, with which I will be very consistent towards leading it towards the end of the project. Customers and developers usually focus all their attention on this functional requirement primarily because everybody else would concentrate on non-functional requirements, projecting their product as the best quality product. But then this best quality product would come out with the basic functionalities and the behavior that the system has to do. Talking about the second type of software requirements, which is non-functional requirements, which has to do a lot on the quality of the system. Non-functional requirements are basically of three categories: product requirements, process requirements, and external requirements. If you are very specific about the product requirements, I will be looking at usability, efficiency, portability, reliability, performance, and space. Efficiency has to do a lot on the performance and the space constraints. When I say the product is more efficient, then I may have to talk from the terms of how accurate the response to the system is, or the response to the system are. How accurate, what is the deviation that I find? So those are to be, or what is the noise that I have identified from the system? Those are the performance measures which I can take it when I do a system. Not only on that, at times I may am restricted towards the space also. How much capacity or how much volume does this consume in completing this task? So this is a specific requirements towards product requirement, where efficiency is one of the key point. Not only that, reliability requirements, where when we talk about reliability, how reliable, how trustworthy this project is, or how portable. Can it be transformed from one operating system to other operating system? Can it be taken across platforms? All these things can be thought of. Looking at the process requirements entirely talks about how it is to be delivered and meet the standards. So it will talk more on delivery requirements, implementation requirements, and standard requirements. So the flow with which I am adopting to the system is more on the process, by where at the end of the phase I will be looking at the benchmark towards the system. So if I am adopting to some standards that has been already been given, then the standards are automatic. That's the reason why we have initially indicated on the different software development lifecycle models. So because of consuming those software development lifecycle models, most of the systems, if they don't want to go in for a major failure, they get on to a requirements phase, design phase, coding phase, and testing phase. And today so many of the systems which adopt to agile strategies, basically because of the experience that they have gained by doing all these projects, they can reduce the number of, or they can reduce the volume of defects. But for startups, they will be preferring to the conventional software development lifecycle models. And the third category of requirement is external requirements, where we talk about interoperability, ethical requirements, legislative requirements like privacy and safety. So anything that has been compromising, or these portions of the categories of non-functional requirements, would not fetch a very good quality system. So non-functional requirements, apart from the technicality of the project, apart from the behavioral capacity of the project, this non-functional requirements prove ourselves that this is a quality project to the end user community. Now we will look at the team that is to be developed for effective requirements management process. So what should be the capacity of the team, or what should be the skill that the team needs to have as a requirements engineer? A requirements engineer need to have an in-depth analysis of the problem. Specified a specific problem, he should not take the problem in a conventional way, rather he should be very clear on the pessimistic and optimistic way of thinking on the same problem. Understanding the user and stakeholder needs, defining what is required for the system, managing the scope, refining the system definition, and he should take us towards building the right type of a system. So these are the basic skills that a requirements engineer need to possess. And if you look at the same requirements engineer and what are the tasks that this requirements engineer has to do, he may have to initially define the various business needs, identify who the project stakeholders are, and should clearly define what are the classes, user classes. Not only that, he may have to gather all the requirements, analyze on the requirements, not on the entire phases, but to specific problems at times where the possibility of error might be too heavy. So we may have to analyze on those requirements in depth, write specifications. The ultimate objective after passing through this software requirements phases, we may have to specify correctly what is to be developed with its scope, objective, motivation, and the outcomes. Once having gone through this requirements phase, at any point a developer should not have a doubt of why this is needed. So we are analyzing on the entire problem and we are writing a clear specification which is to be consistent and clear. Then we will try to convert the requirements into a model which will be taken forward towards validation, and it is facilitated based upon its prioritization, and we are about to manage the requirements till the end of the development. Having looked at a process, requirements engineering process is being carried out in 4 different phases. That is what I have indicated here. Requirements engineering process happens quite fortunately with the help of stakeholders. So the active participation of all the stakeholders is pretty much essential when I am at the requirements phase. So with which I will keep myself aside and start developing towards my design, code and test. But for that I don't majorly require the help of the stakeholders or the customers. So at the requirements phase, I am making myself clear what the stakeholders and the customers wanted. So I majorly require the active participation of my stakeholders. So what I do is I carry out this requirements engineering into 4 phases. First phase is elicitation phase, second one as analysis phase, third one as documentation, and finally I do a validation. At elicitation level, I work with the customers on gathering all the requirements that they are very clear on. Then I try to elaborate all those requirements, process this information to understand it clearly, classify each and every level of understanding into various categories, and relate everything to the customer needs to possible software requirements. Not only that, I clearly come out with a specification wherein I give a complete structure, the customer input and derived requirements as written documents and diagrams. So by where I am making myself clear in not deviating on anything, thereby I am reducing the communication space. So this communication gap can occur at any point in time between the customer and the developer, that need to be avoided in the beginning stages. So what I do is I structure myself very clearly by taking up all the requirements and I elaborate to the customer, specifying that these are the inputs that are being given to the development and everything has been documented and this is how we are about to implement. So a simple pictorial representation would give them a clarity on how the system will go for the next stage. Finally, it has to be validated, and they'll ask the customer to confirm that what you have been written is accurate and complete to correct the errors that is occurring. Finally, after taking the entire validation, it will get on to a requirements management perspective, where there might be change management, and it might lead us to communicate to relevant stakeholders also. This requirements engineering is being carried at two different levels. One is requirements development level and the requirements management level. So far what we have been seeing is, we have been seeing only to the requirements development level, where we have done elicitation, analysis, specification and validation. So when I am at the elicitation phase, I will majorly involve the participation of stakeholders. I will consult, review, and the context of normalization is being taken up with active participation of stakeholder. At the analysis level, the understanding of desired system that need to be developed with this statistical information is being done. For specifying, I will go for a structured documentation of desired system, and for validation I will go for identification of omitted, redundant and inconsistent requirements management. When I am at the requirements management phase, it is not on the elicitation, analysis, specification and validation, it is more towards the traceability, where if this has been found to be wrong, where did I leave in the beginning. So I need to have a traceability scenario where I have to track where the requirements are to be met. Not only that, I need change management where the requirements maintenance and propagation also to be taken care of. Not only that, and I need a fulfillment phase where result and confirmation of successful fulfillment need to be established. In short, in this particular lecture we have learnt about what requirements are. So we have understood that requirements talks us only about what of the system rather than saying about how of the system. And we have understood on the importance of these requirements towards the development of the software. Further, we have indicated the different types of software requirements, whereby you divide this into two different types. One is functional requirements, the other one becomes non-functional requirements. Functional requirements typically talk about what sort of input need to be given to the system, how does the system behave, and what will be the output of the system. Whereas when we look at the non-functional terms of it, we look at the major qualities of the system or how the system responds to the queries. So in terms of the process, in terms of the product, in terms of the requirements. So thereby we have understood what is reliability, performance and all these efficiency point of it. So the quality of the system will be the prime importance when it comes to the non-functional requirements. Further, we have understood that we need a person who is called a requirements engineer, who should basically possess some skill and who has to execute some task towards this requirements engineering phase. And this requirements engineering process has been further understood. Thank you.